All right, welcome to The Explainer. Today we're going to break down everything you absolutely need to know about web protocols and security, specifically for your Year 12 exam and that big Flask project you're working on. So, are you ready to build a web app that not only works, but is secure enough to ace that practical exam? Good. Let's dive right into the core concepts that are going to take your app from just a basic project to something that's genuinely secure, professional, and, actually hits all those marks you're being graded on. So here's our game plan. First, we'll follow the journey of a single web request from start to finish. Then we'll get into APIs, basically how your app talks to the server. After that, we'll tackle the difference between JSON and SQL. Then, the really important part, defending your app from attacks. And we'll wrap it all up with a super quick cheat sheet of everything you need to remember. All right, section 1, the secure web journey. Let's start at the very beginning. We're talking about that foundational process that happens every single time you type a web address into your browser and hit enter, especially when it's a secure one. The best way to think about this whole thing, it's like a secure package delivery. Seriously, you've got all these different protocols, and really, protocols are just a fancy word for a set of rules, and they all work together, kind of like layers of an onion, to get information from a server all the way to your browser safely. So let's look at this protocol stack. Each step has one very specific job. First, you've got DNS, the domain name system. Think of it as the internet's address book. It turns a name you can remember, like google.com, into an IP address the computer understands. It finds the house. Then comes TCP. This is the reliable road. It makes sure all the little packets of data arrive, and just as important, that they arrive in the right order. Next up, TLS. This is the locked van. This is what actually encrypts your data, scrambling it so no one can read it in transit. And finally, you have HTTPS, which is like the delivery paperwork that defines the rules for the whole conversation. See how they build on each other? It's this stack that creates that secure connection. Okay, so let's zoom in on HTTPS and TLS for a second. There are two main goals here, and you really need to get this. First, there's confidentiality, which is just keeping your data private. That's the encryption part. But just as important is authentication. This is about proving the server is who it says it is. It's what makes sure you're talking to your actual bank and not some scammer's website that looks just like it. So it's not just about privacy, it's also about trust. So how do they establish that trust? Through something called the TLS handshake. It happens in a split second before any of your real data gets sent. Your browser basically says hello to the server. The server says hello back and shows its ID, which is a digital certificate. Your browser then does a background check on that certificate. Is it valid? Is it from a trusted source? Is it for the right website? If everything checks out, they secretly agree on a special key, a code just for this one session. And only then, once that handshake is complete, do they start exchanging the actual encrypted information. All right, so our secure connection is up and running. Awesome. But now, how does your web app actually do stuff? How does it feel fast and modern, updating things on the page without that clunky full-page reload every time you click a button? That's where APIs come in. So what is an API? It's an application programming interface. Basically, it's a set of rules that lets your front end, the JavaScript running in the user's browser, talk to your backend, which is your Flask server. For your project, this is absolutely huge. Instead of refreshing the whole page just to show a new comment, an API lets your JavaScript say, hey server, just give me that new comment. It's how you create that smooth, slick, modern user experience that everyone expects. Now this table right here, this is basically your roadmap for building your Flask API. Every basic database action, we call them CRUD actions for create, read, update, and delete, maps directly to a specific HTTP verb. When you want to create a new user, you use post. When you want to read some data, like a list of posts, you use get. To update a profile, it's put or patch. And to delete something, you use delete. You have to get this right. It's not a suggestion, it's the standard. Using the right verb for the right action is fundamental to building a proper API. Okay, so your API is zipping data back and forth. But what does that data actually look like? What format is it in? And once the server gets it, where does it go? Where does it live permanently? This brings us to two crucial but very different technologies, JSON and SQL. Getting the difference between these two is so important for your project. Think of it this way. JSON is for moving data. It's the lightweight message, the letter in the envelope, that gets sent between the browser and your server. It's the language of APIs. But SQL is for storing data. It's the language your server uses to talk to the database, which is like the giant permanent library where all your information is carefully organized and kept safe. Here's a great way to picture it. Think of a bank teller. The JSON is the little request slip you fill out and hand over the counter. I'd like to deposit this, or please show me my balance. Your Flask server is the teller. It takes your JSON slip, reads it, and then turns around and uses a totally different language, SQL, to talk to the secure vault in the back, which is your database. The JSON is the request, the SQL is the action. Okay, let's switch gears. Your app is built, the data is flowing, but is it safe? We absolutely have to talk about security. And let me be clear, this isn't some optional extra credit thing. Protecting your app from common attacks is a fundamental requirement of your project. And it all starts with this, the #1 rule of web security. If you remember nothing else, remember this. Never trust user input. I mean it. You have to assume that every single piece of data coming from a user's browser, whether it's in a search box, a comment form, even the URL itself, is potentially malicious and designed to break your app. So what happens when you trust user input? You get things like SQL injection. This is one of the most classic and most devastating web attacks out there. And defending against it? Yeah, that's a non-negotiable part of your grade. It's when an attacker cleverly types SQL commands into a normal input field, like a login box. If your app is built carelessly, it might just stitch that malicious code right into its own database query and run it. The result? The attacker could potentially steal or even delete your entire database. So this here is your security playbook. It's a game of if they do this, you do that. The attack is SQL injection. Your defense is to use parameterized queries. We'll talk more about those in a sec, but they basically keep the user's data separate from your commands. The attack is cross-site scripting, or XSS, where they inject malicious JavaScript. Your defense is a content security policy, or CSP. And what about cross-site request forgery, or CSRF, which tricks a user into doing something they didn't mean to? Your defense is an anti-CSRF token. You need to know these pairings cold. This leads to a super important point about handling user input. You need to validate it, always. Check that it's the right type, the right length, the right format, and you have to do this on the server. Look, client-side validation, the JavaScript stuff that pops up an error message right away, that's great for user experience. It's helpful. But it is not a security feature. An attacker can easily bypass it. The real authoritative check, the one that actually protects your database, must happen on your Flask server. No exceptions. Okay, deep breath. We've covered a lot, so let's do a rapid-fire review. This is your exam cheat sheet. These are the absolute must-know concepts you need to lock in. First up, HTTPS/TLS. How many goals does it have? 2. Don't forget it. Confidentiality, which means privacy, and authentication, which means trust. It keeps things secret, and it proves you're talking to the right server. Next, JSON versus SQL. What's the difference? Super simple. JSON moves data. SQL stores data. JSON is the message. SQL is the library. Okay, SQL injection. What is your #1 absolute best defense? Parameterized queries. Say it with me. Parameterized queries. If you only remember one security term for your exam, this is it. It's the mechanism that separates the command from the data, which makes this whole class of attack basically impossible. And finally, the golden rules. Know your HTTP verbs. Post creates, get reads, put updates, delete deletes. Get that right in your API. And the most important rule of all, the one we keep coming back to, say it again, always validate user input on the server. So there you have it. You've built your app, you've followed the rules, you've put in the defenses, but here's the final question to leave you with. How will you actually test that it all works? Building it is one thing, but thinking like an attacker and trying to break your own app, that's how you really know it's secure. That's it for this explainer. Good luck on your project and good luck on the exam.